Hi, in this episode we're going to solve quadratic equations using the quadratic formula. The quadratic formula is the go-to option when you cannot solve by square roots and the quadratic cannot be factored. It's our last resort. It will work on any equation that is of the quadratic form with a squared in it. So we're going to have simple steps. And the first step is going to be we're going to have to modify it so that it is equal to 0. So we're going to have to move some things around through operations to ensure that the quadratic is equal to 0. The next thing is we're going to determine a, b, and c. This is one of the most important parts. A is determined by what is attached to the x squared. B is the coefficient on the x, and c is the constant. So it's not necessarily in the order of a, b, and c. It is by what it is attached to. So a, the coefficient on x squared, b, the coefficient on x, and c is the constant. The next thing we're going to do is find the discriminant. And that's what we're going to pick up right now. The discriminant is part of the quadratic formula. The discriminant is b squared minus 4ac. If you notice within the quadratic formula as well, it is the part that is under the square root. So we're going to find the discriminant. The discriminant is going to tell us some things about this, and what it's going to tell us is how many solutions it has based on the value of it. So we'll come back to this one in a second. So let's take example 1 and let's find the discriminant really fast. It's b squared minus 4ac. Remember, one of our first steps though is determining what a, b, and c are. So I'm going to, over here, put a equals, b equals, and c equals. So a is the number, or the coefficient on the x squared. That number is 2. B is the coefficient on the x, that is negative 5, and c is the constant, or just 3. So as we take this, we're going to simplify it, substitute it in, and then simplify it. And I put parentheses where I have to simplify, or where I have to substitute items in. So b was negative 5. It's in parentheses, and it's being squared. Here we have the value of a, that's 2, and the value of c, which is 3. Now I'm going to simplify this down. Negative 5 times negative 5 is 25. Minus, it's negative 4 times 2 times 3. When you multiply those together, you get 24. So we find our discriminant to be 1. When we find the discriminant to be 1, we're going to take that and we're going to substitute that into the quadratic equation. So we have x equals the opposite of b plus or minus the square root. And remember, the discriminant is what goes inside there. So we found the discriminant, we found that portion to be 1. It goes inside the square root. And then it's all over 2 times a. So instead of these variables, I'm going to go ahead and just open parentheses. So the opposite of b, negative 5. So notice it's negative 5. And then 2 times a was 2. The next thing I'm going to do is I'm going to simplify this down. So negative 5 is positive 5, plus or minus the square root of 1. The square root of 1 is 1, and that's all over 4. Now, I have a positive version and a negative version. So I can add 1, and then in a second case, I would subtract 1. So 5 plus 1 all over 4. And then 5 minus 1 all over 4. And simplifying these down, we get 6 over 4, which is 3 over 2, as one solution. And then 5 minus 1 is 4 over 4, which is just 1. So that's a second solution. Going back to this idea of the discriminant tells us how many solutions this has. So when we found the discriminant, to be positive 1. When we substitute that into the quadratic formula, the square root of 1 is going to give us a certain value. We're going to have the positive version and the negative version of that giving 2 answers. So since it's 2 answers, and they're both real, 3 halves and 1 are both real, so that would be a positive discriminant. If we have a negative discriminant, then within this, it would be a negative value, and we can't do the square root of a negative value, so that would tell us no real solutions. So no real solutions would be a negative discriminant. And then if we have one real solution, that's when the discriminant is 0. When the discriminant is 0, then we have plus or minus the square root of 0, which is 0. So plus or minus 0 is going to give us the same answer twice, which is only going to be one answer. So the discriminant tells us a lot about how many solutions it has. Again, if the discriminant is positive, it has 2 real. If it's 0, it's 1 real. And if it's negative, it's no real solutions. So looking back at this, we could have seen positive discriminant, 2 real solutions. Now, let's move on to a second example. This example, it's not equal to 0, so we need to do some operations so that it is. That would be adding 4 to both sides. So we have 2x squared plus 3x plus 4 is equal to 0. That's step 1. Step 2 is determine what a, b, and c are. So a is 2, b is the number on the x, which is 3, and c is the constant, 4. Now, step number 3 is to find the discriminant. The discriminant, b squared minus 4ac. Finding that, we have substitution, so 3 goes in for b. A is 2, c is 4. So we end up with 9 minus 32. So for our discriminant, we get negative 23. So that's just finding the discriminant. Now, since that discriminant is negative, we can go to the quadratic formula and substitute it in so it's under the square root. So let's just see what it looks like really quick. So we have opposite b plus or minus the square root of negative 23 all over 2 times a. And that's x equals. When we look at this, the square root of negative 23 we simply cannot do in the real sense. So this has no real solutions. And that's what we would write. We don't have to go any farther. We don't have to even attempt to simplify it. So we're going to just write no real solutions. So again, going back to this, the discriminant was negative, no real solutions, because we can't take the square root of a negative number. So in quick review, we're going to first make sure it's set equal to 0. The next thing we're going to do is identify a, b, and c, c being the constant, b is on the x, a is on the x squared. Then we're going to find the discriminant, b squared minus 4ac. That discriminant is part of the quadratic formula that substitutes in along with the other portions of it. We simplify it down, we consider all cases such as 5 plus or minus 1, and then we simplify it down and find the answers. So this is how you solve with the quadratic formula. Again, really, really helpful if it cannot factor and we cannot solve by square roots. Thanks for joining us. Tune in next time.